Hello everyone, I'm Paul and today we're solving problem 120, triangle. This is a medium one that's interesting for me, so next I will show you my intuition, approach, and efficient solution. We are given a 2D array representing a triangle, so for example we are given this. And we need to return the minimum path sum from top to bottom. So if we are given this is the corresponding triangle, and here the result is 2 plus 3 plus 5 plus 1, and this is 11, and this is the minimum path sum that we can get for this triangle, so we return 11. Now maybe you're thinking about going from top to bottom and taking the minimum value each time. So maybe you're thinking about starting with 2, then with 3, then with 5, then with 1, and this is how you can get 11. But we have a problem here. Let's say we're given this triangle. If we do the same here, the sum would be 2 plus the minimum among these two, which is 1, 3, plus the minimum among these two, which is 9. And this is 12. But this is not the minimum path sum for this example. The minimum path sum here is 2 plus 5 plus 1, which is 8. So this strategy won't work. We need to think about something else. So it would be great if we could somehow store the solutions from previous rows. Let's say we are at this row and we know that the minimum path sum at this point is 2. And from here we can take the minimum path sum for the previous row and add the current value. And we are storing results from previous rows and we are using those results in new rows. And this is dynamic programming. So we can store the minimum path sum up to each number, and we don't even need to build a new DP array. We can use this triangle that we are given. So first we are here and the minimum path sum up to this number is 2. So we keep 2 here. Next we are here and the minimum path sum up to this moment is the previous minimum path sum, meaning 2, plus the current value, 3. So we replace this with 3. Now here we do 2 plus 5, which is 7. Now we are in this row, so we do the same. We start here and we take the previous minimum path sum, which is 3, and we add the current value, so here we get 13. Now we are here and we take the minimum among these two minimum path sums, which is 3, so we do 3 plus 9, and the result for this is 12. Finally here we do 7 plus 1, which is 8. Finally we can take the minimum in this row, which is 8, so we just return 8. Now there's one last thing that I want to talk about, and it's that I try to think about triangles with this shape. I think this is more intuitive. So in this column we have this, in the next column we have this, and in the next column we have this. So let's say we're here, and from here we have access to this 5 and this 1. I think this is overall more intuitive. We can check for the same column in the previous row or the previous column in the previous row. If we are here, we can't check the same column in the previous row. This is an empty space. We can only check for the previous column in the previous row, meaning this. So with this in mind, let's go with the code. So we're given a triangle and we need to store the minimum path sum at each point in this same triangle. We don't even need to build a new triangle, so we are using this triangle. So we have a nested for loop for I in range from 1 to the length of triangle, meaning the amount of rows, and regarding columns for j in range the length of the current row, triangle I. And if we are standing in the column number 0, this means that we only have access to the value that's in the previous row and the same column. Remember our drawing. So in this case, triangle I j plus equal triangle I minus 1 in the same column. Now, if we are standing in the last column, meaning if j is the length of triangle I minus 1, we are in the last column, we know that we don't have anything in the previous row and the same column. We only have a value in the previous row and the previous column. So in this case, triangle ij plus equal triangle I minus 1 j minus 1. Else, this means that we are somewhere in the middle, and this means that we have access to the value that's in the previous row and the previous column, and in the previous row and the same column. So we need to take the minimum among these two minimum path sums and add the corresponding value for the current number. So triangle ij plus equal the minimum among triangle I minus 1 j and triangle I minus 1 j minus 1. And finally, we can just return the minimum value in the last row, meaning triangle minus 1. So this is it for the code. I think this is right. Now let's submit this and see if it works. As you can see, this works and it's very efficient. Here we are iterating every value in the triangle only once, so time complexity will be big O of the amount of rows square, roughly, and the space complexity will be big O of 1 because we are using the same triangle that we were given. So this is it for the code. If you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.